box plot. So this is quite self-explanatory. We are plotting what looks a bit like a box, but it's kind of a box with arms. So I'll draw like what one looks like. Okay, so this is what a box plot actually looks like. So a bit strange, but as we can see, sort of the box. So let's run through some theory, and then we'll go on to 2 exam questions. So firstly, what are all these lines telling us? What is the box and why? What we want to know is what box plots that is really hard to say. We really want to know what box plots actually measure. So what they measure is range. So range, just as we know in averages, the highest value take away the smallest value, and also this thing called IQR, which is interquartile range. So they measure range, so spread within the data. So the interquartile range is, in data you get the things called the quartiles. You get the first quartile, second quartile, and the third quartile. The second quartile is a fancy name for the median, the middle value, the medial value. The quartile 1 and quartile 3, the ones that aren't middle values, are the quarter ones. So it's quite self-explanatory. So quartile 1 is the value that's a quarter in, and quartile 3 is the value that's 3/4 in, and quartile 2 is the middle one. So the interquartile range is quartile 3 take away quartile 1, and the interquartile range is this bit here. So from looking at our plot, we know the interquartile range is Q3 minus Q1, quartile 3 minus quartile 1. So here we have Q3. So this point here, which you would plot, is the third quartile. This point here you would plot is the first quartile, and this is called the lower quartile, and this is called the upper quartile. So it's kind of splitting your data up into quarters and then looking at those values and plotting them. So the interquartile range is the upper quartile, Q3, minus the lower quartile, Q1, and that's where they're plotted in the graph. So that's the range it shows, spread it measures there. This one in the middle is Q2, which is the median. So on this slide, you'd plot the median, then you would draw a line, you'd plot the lower quartile and the upper quartile, and you draw a line and make a box. So what are these reaching out arms? So this here is the highest value, and yep, as you guessed, this here is the lowest value that you obtain in your data. So if you take away the highest and the lowest value, you get the range, so that you get that spread. So let's look at some perks. So the range, however, can be affected by outliers, and outliers are things like a bit dodgy values, so when someone might have put data in wrong or they're just a bit abnormal. So range is affected by outliers as it uses all the data. So that's kind of a downside to range. Interquartile range is not affected by outliers. So that's kind of a bonus of interquartile range. And the reason this is because it's using 50% of the data. So it's using the middle 50% instead of being affected by like maybe weird points. You might have had a weird outlier there, but all the values actually stop there. Okay, so I hope I've explained that okay. So we know that these tails, lowest value, highest value, these are our quartiles. So middle is median, medial value, and then these are our quartiles, which are splitting our data into quarter and then marking down that data point. This here measures the interquartile range spread, that's a Q, and then the whole range is here. The whole range, however, can be affected by outliers as it uses all the data, so a bit funny points that don't really make sense with every other data point you have. And interquartile range is better because it is less affected by outliers because it's using the middle 50% of the data. Okay, so we need to know how to work out the lower quartile, median, and upper quartile points. We know that how to do the middle one is you list them all in ascending order and you find the middle value. Another way to do this would be, so Q2 is the n plus 1 over 2, where n is the number of data you've collected. So it's that value point in your data. So let's say I had, I don't know, 7 pieces of data. That means Q2 would be 7 plus 1, which is 8, divided by 2, which is 4. So then it would be the 4th data point into my data. Q1, this will be a lot easier with an example, is n plus 1 but divided by 4 to get the first quarter. So quarter, half, and then Q3 is n plus 1, but you do 3 over 4, and you can think of that as the 3/4 point. Okay, so let's do 2 exam questions. Okay, so this is the first question. So we've got a table shows weight in grams of some potatoes, and this is our table. So it's given us the range, the Q1, the lower quartile, Q2, the median, Q3, the upper quartile, and the maximum value. Draw a box plot of this data, and then it gives you this scale. It has little grids in, but not really able to draw that on this situation. So first of all, information we know. So we're literally given the maximum value, so I'm just going to plot the maximum value. So again, it's going to be quite rough. So if that's 180, that would be 190, so it's going to be about here. So that's the max. Okay, what about Q3? Let's plot that. So 162, quite rough. You're going to have to be more. When you have the little grids, you can be really much more accurate. That's the word. So that's Q3. Q2 is 132, so 130 will be about there, so 132 we're going to go for there. Again, got to be more accurate. Q2, the median, lower quartile is 110, so about there. Q1. So we can plot so far what we know about that. So we know that we know it's going to look something like that, but maybe just not as symmetrical. So we knew the max value, the highest value was this, so we can draw that tail there. Okay, and we know these lines, that was Q3, Q2, Q1, so we can draw bigger lines for Q3, median, please use a ruler. And we know that's our box plot, so we can draw that. We can sort of secure that up, and then we can add, we know the maximum value, so we can add this tail here. So we're missing one value, and that is the arm on this side, so the minimum value. So the min. But we are given the range. So what do we know about the range? We know range is highest, take away, lowest value. So we know the range, we can sub that in, 101 from reading the table. We know our highest value from, again, the table is 185, take away, and we're looking for the min value. So why don't we rearrange? So if we take the minimum over this side, and we take the 101 over that side, so minimum becomes positive because you brought it over this side, then you're going to have 185 minus 101. That equals 84. So now we know the min value, which is the only value we're missing, it's 84, so 84 is about there. Again, be more accurate than about there, and then we can do that. So it's actually not too bad. So there'll be something like that. A lot of the time they give you tables with some information, some quartiles, maybe the interquartile range, maximum values, they'll mix it up. But yeah, ultimately you just need to know what you're plotting where. So let's do one more. Okay, so this is our next question. So we have the weights in kg of 11 pigs are recorded below. Given our data, draw a box plot. So firstly, what do we need to know for a box plot? So the thing that looks like a bit weird with the boxes. So, things we need to know, let's list them. We need to know the highest value. Do we know what that is? So it seems to be in ascending order, so we know it's 91. We need to know the lowest value. So we've got that point and that point. What's the lowest value? Again, so we'll just pick the smallest one. Okay, we need to know Q2, which is the median. So now we can use these equations that I showed you earlier. So Q2, actually I'll write them all out. So Q1 was n plus 1, so there's your quarter, the first quarter. Then you have your halfway point. Then you have your third, which is your 3/4 point. So in this case, n is 11 because there are 11 pigs. So what do we have? For Q2, we're going to have 11 plus 1 divided by 2, which is 12 divided by 2, 6. So we want the sixth value in is Q2. So 1, 2, 3, 4, 5, 6. Okay, so the median is 69. What about Q1? So going back to this, Q1 is going to be 11 plus 1 divided by 4, which is 12, divided by 4, which is 3. So we want the third value in. Do not write 3 down, because that's actually not in our data. 1, 2, 3. 59. Let's go on to Q3. So we have 3 times n plus 1, which is 11 plus 1, which is 12, divided by 4. So 3 times 12 is 36, divided by 4 is 9. So we want the ninth value in. So this is, again, you can't just write 9 down because 9 isn't a point in our data, so it's kind of obvious you can't write 9 down. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is a point that is 3/4 of our way in. So Q should probably stick to the same colours. Q3 is 80. So now we have the 5 points we need to know to be able to plot this. I'm going to rub this out so I can make room to plot. Okay, so here's the number line. Don't forget to, 1, label what it is, and 2, sometimes it can be quite difficult working out the scale, but just kind of stick with it. If you draw one that looks too tiny and weird, then maybe, double it, or again, if you realise you can't fit, maybe half it, try and make it fit on there. So, firstly, highest value, 91. So I'm going to put that is here. Lowest value is 48, so that's about here. Again, be more accurate. 69 is the middle value, that's about here. Q1 is 59, which is about here. Q3 is 80. You should know for these middle ones, the quartiles, you draw the box, and then that would be the interquartile range, and then these two are the hands. So this isn't actually on the question, but what if I wanted you to work out the interquartile range? So that is this range bit here. So I can either read it off the graph, but my graph's a bit too messy to read. So it's Q3, so this distance here, whatever. So it's Q3 minus Q1. So again, you could read it off your plot you've just drawn, but mine's too inaccurate to read it off. So Q3 is 80 minus Q1, which is 59. So 80 minus 59 is 21, so that would be your interquartile range. What if I just wanted to calculate the range? So I know that's the highest value, high minus low, which again you could read off your plot, but mine's too messy. 91 minus 48, which would be 43.